guys, welcome to another teaching video with Mrs. Jockel. Today we're going to focus on math from our Go Math book. So if you do not have your Go Math book right in front of you and a pencil, please pause this video and go grab those materials. Now we are starting in chapter 12. I know we were only in chapter 10 before school closed. But we are jumping ahead to chapter 12, so we are on the same page with all of the other third grade students. And then we will be going back and covering the rest of chapter 10 and chapter 11. So if you would open up your math book to pages 697 and 698, and we're going to go ahead and get started with lesson 1. So boys and girls, chapter 12 is all about geometry, and geometry has to do with different shapes. So we are going to start with two-dimensional shapes, which means they are flat shapes drawn on paper, and then we will work our way into learning what some three-dimensional shapes are. So if we look at our Unlock the Problem, it talks about an architect. An architect is someone who draws plans for houses, stores, offices, and other buildings. So if you look at the picture here to the right in that green box, I'm sure you can locate different shapes. I see on the doors, some rectangles, the window's a rectangle, even the upper windows are shapes maybe that don't have necessarily a specific name because they have some curved sides to them. The roof is in the shape of a triangle. You could imagine drawing the bottom segment of the triangle there. So in the real world all around us, there are shapes that we can pick out. And when we put these shapes together, we can create buildings and statues and all kinds of things. So it talks about a plane shape. Now, it's not plain like there's nothing on it, and it's not plain like an airplane. In math, a plane shape is a shape on a flat surface. It is formed by points that make curved paths, line segments, or both. So we're talking about like a flat plane being on like paper. That would create a plane shape. So in order to move further, we have some more vocabulary words here that you see are highlighted in yellow that we need to take a look at. So when we refer to a point is an exact position or location. So it is like a point, like a period is a point. That is a point that I just made. It is an exact position or location. So in social studies, when we look at maps and we see cities located within states, and usually cities are located by a point because they are exact locations on a map. Now we go to a line. A line is a straight path. It continues in both directions and it does not end. So you can see at the end of the line, it has these arrows. Those arrows indicate that it's going on and on and on and on in both of those directions. So a line does not end. It continues on in both directions. Now we go down to endpoints. Endpoints are the points that are used to show segments of a line. Boys and girls, segment means part of something. When you think of an earthworm, I'm sure many of us have seen a lot of earthworms out because it's been so rainy, but earthworms, their bodies are made up of different segments, different sections. So when we talk about endpoints, you see here how they put a point. Remember, we learned about points up here. They put a point at the end of the line. So now this line actually does not continue on and on. It stops. It would be showing part of a line. And therefore, that takes us over to line segments. It has to be straight, and it's showing part of a line, and it has these two endpoints. I like to refer to those endpoints as kind of like stop signs because that's the extent of the line. That's where it stops. And so just to give you a better idea of a line segment, if we go up here to our line and I make 2 points on the line, between my 2 endpoints, that creates a line segment. So you can kind of see that these endpoints, can't really draw a straight line here. This would create the segment in between these 2 endpoints. So what we need to understand is that a line continues on in both directions forever and ever. A line segment does not. It has endpoints that stop. And so a line segment is only as big as you show it within those 2 endpoints. And then there's something that's kind of a combination of both a line and a line segment, and that is called a ray. And I like to think of a ray as, the sun, because you think of the sun's rays shining down. And so a ray is straight. It's part of a line. It has one end point, but then it continues on forever in one direction. So if you think of like the sun, here's my quick little picture of the sun over here. And then the rays of sun that shine down to us, and they are following one direction to reach us on Earth. So a ray, I always think of a ray of sunshine. It has one ending point because it stops here at the sun, and then it's continuing on in one direction towards us. So a ray is kind of a combination of a line and a line segment. All right, if we move down here to the bottom of the page, it says that some plane shapes are made by connecting line segments at their endpoints. One example is a square. So it says to describe a square using math words. First of all, let's just take a look at the square. We can see here, these are the endpoints. And within the endpoints, we have line segments. From one endpoint to another, that is a line segment. So over here it says to think, how many line segments and endpoints does a square have? Think for a minute. A square has 1, 2, 3, 4 line segments, and the line segments meet only at their endpoints. Each corner of the square is an endpoint where the line segments are meeting, where they touch. So here we would need to type in endpoints. See if I can type that. Whoop. All right. Trying to finagle all this. Technology has been challenging, but we'll get there. All right. Okay, now we can move on to the next page. Remember, plane shapes have length and width, but no thickness because they are flat. These are flat shapes. And so that is what we call two-dimensional shapes, or 2D. I know many of us have heard of 3D, but 2D is these flat shapes that we draw on paper because they don't have any thickness to them. They don't have any depth. They only have a length, how long it is, and its width, how tall it is. So if we take a look, it talks about plane shapes, how they can be open or closed. Very simple vocabulary words, boys and girls, because closed means it is connected or it is shut, like when you close the door. So a closed shape starts and ends at the same point. So if you take a look at the closed shapes they drew as examples, we have a shape that looks like a circle. We have one that almost kind of looks like a letter B, a square, a triangle, one that looks like Pac-Man in the middle, and then also one that maybe looks like an hourglass or, I don't know, some kind of scientific you know, measuring tool or something. But either way, all of these shapes are closed. They all are connected. So they want us to practice drawing some closed shapes. So I'm just trying to think of some shapes here that I could draw that are closed. Maybe a heart. There we go. A heart is a closed shape. We could just make, I don't know, any kind of shape really, as long as we have it closed and connecting. I don't know, that's kind of like a sideways T. Maybe some stairs. Sadie said a circle. Yeah, a circle is a closed shape. So as long as your shapes are closed, you created closed shapes. All right. So the opposite of closed is open. So therefore, an open shape does not start and end at the same point. So you can see, you know, like a zigzag or a letter S, or, you know, this shape at the bottom almost looks like a rectangle. It's just missing one more line segment. So those shapes are all considered to be open shapes. So you could draw your own open shape. I'm not going to close it. So that would be an open plane shape. Something like that would be an open plane shape. If I went to draw a heart but I didn't finish it, that would be an open shape. So you get the idea, I think, that closed means they have to connect, and open means just that. They are open. They do not close or end at the same point. So last question on this page asks us, is the plane shape at the right a closed shape or an open shape? Explain how you know. Well, when I look at the shape, I could start at any end point and I can trace along, and I can see that where I started is also where I end, where it closes. So I would say that this is a closed shape. Let's see, I'm going to move my words over here and shrink them down a little bit so you can write along with me. Okay, closed shape, because we have to explain how we know this, because it starts and ends at the same point. That's how we know this is a closed shape. Okay? Once you have that written, we will continue on to the next page, which is our share and show. So on the share and show, we're just looking at some more of these plain figures. Remember, these are all two-dimensional because they are flat on our paper. Number 1 says to write how many line segments the shape has. Remember, a line segment is a part of the line. It has those endpoints, so it does not continue on and on and on. It doesn't have those arrow tips. So a line segment has a starting and an ending point. And so when we look at this shape, I think we would know that we would call this shape a triangle, and tri means 3. So this shape has 3 line segments. Line segments are just fancy for the sides, boys and girls. When you were in kindergarten, I'm sure, or even preschool, you learned that a triangle is a shape with 3 sides. Now that you are a fancy, smart 3rd grader, mathematically we can say, this shape has 3 line segments. All right, number 2 says to circle all the words that describe the shape. So when I look at this first one, number 2, I see that it has an end point, but then it continues on and on and on, and it has that arrow. So this was what reminded me of the sun, because it's a ray, like a ray of sunshine, starting at the sun and beaming down to earth. Number 3 is a shape that has 4 sides, and as I trace along the segments or the sides, I started and ended at the same point. So this is a closed shape. Number 4, I think, is pretty obvious. We can see that because it does not start and end at the same point, it is an open shape. And number 5, again, we see these 2 end points. It does not continue on and on and on, so we would call this a line segment. Okay? Going down to number 6 through 9, we need to write whether the shape is open or closed. So if we look at number 6, ask yourself, does the shape start and end at the same points? I think we can see that it does not, so this would be an open shape. Okay? Number 7 is closed. It has curved sides, but it does connect, and so we would call it a closed shape. Number 8 is also a closed shape because it connects. It starts and ends at the same point. And number 9 is an open plane figure because there's that one little piece that's missing. So that would be open. Pretty simple so far, right, boys and girls? All right, number 10, on your own, you could pause the video right now if you would like and do these next few problems on your own and then hit play to check over your work, or you can just keep working along with me. But it wants us to write down how many line segments the shape has. Again, I will remind you, a line segment goes from one end point down to another end point. It's just a fancier word for the sides of a shape. So in this shape, I count 1, 2, 3, 4. So there are 4 line segments in that shape. On number 11, it seems there's a lot more, so I'm going to trace over it so I can keep track. 2, 3, 4, 5, 6, 7, 8. 8 line segments. And we're going to learn what we would call this shape because it has 8 sides. There's a special name for it, just like there's a special name for 4-sided figures too. On number 12, 1, 2, 3, 4. 4 line segments, 4 sides. And on number 13, 1, 2, 3, 4, 5, 6. The shape has 6 line segments. Number 14 through 17, write whether the shape is open or closed. I think you can see number 14, I'm going to put a C for closed because it starts and ends at the same point. Number 15 is an open shape. 16 is closed. And number 17 is closed. All right, nice job so far. If you need a break at any time through this video, feel free to hit pause, go get a drink, grab yourself a snack. I'm trying to keep it short and simple here, but if you need to take a break, by all means, you can do that. You probably wished you could pause me in school sometimes. All right, moving on to our problem solving, boys and girls. This is where we know it gets a little trickier. And so if we look at number 18, what's the error here? Brittany says there are 2 endpoints in the shape shown at the right. Is she correct? Okay, she's saying there are 2 endpoints. So let's take a closer look here. Here is one endpoint I see, but down at the bottom, that's not an endpoint, boys and girls. That's an arrow. So Brittany is not correct because this shape does not have 2 endpoints. It has one endpoint, but then it continues on and on in one direction. So this means, do you remember what shape this would be called? Remember the sun. All right, so we would say no, she's not correct. We clearly can see that. The shape does not have 2 endpoints. No, this is a ray. It has one endpoint, and continues on in the other direction. Okay? Very good. Give you a moment to write that down. Number 19, mathematical practice. It says, explain how you can make the shape at the right a closed shape. Change the shape so it is a closed shape. Well, if we look at the shape, I think I can come up with one very quick, simple solution here to make this closed. I can simply draw one straight line segment, as straight as I can make it, to close the shape. So it had, if we take a look how many line segments it had to start with, it had 1, 2, 3, 4, 5, and then we added on another one. So we could say, draw one more line segment. Okay, draw one more line segment so the shape starts and ends at the same point. And make sure you draw that line segment on the shape to close it up. Alrighty, moving on to number 20, go deeper. Look at Carly's drawing at the right. What did she draw? How is it like a line? How is it different? Change the drawing so that it is a line. All right, so we're being asked to do quite a few things here, so we just need to take it one step at a time. First, we need to figure out, what did she draw? When we look at the shape, I see that it has an arrow at one end and a point at the other. So think, what do we call that kind of shape? So I know she drew a, now this is where I'd be looking for you guys to raise your hands or shout out the answer. So I do miss that aspect of teaching right now, communicating with you boys and girls. She drew a ray. How is it like a line? Well, think of what a line is. A line has 2 arrow points, meaning that it goes on and on and on in both directions. But a ray only has 1 arrow tip, so that means it only goes on forever in one direction. So we could say it continues on in only one direction. Okay, I'm going to add on to that because that's kind of a difference, I guess, you know, that a ray only goes on in one direction, but a line goes on in both directions. So when we think of how these two are similar, a line and a ray both have to be straight. That is a very key concept with these new terms we're learning, boys and girls. So we could say both are straight. Okay, so it continues on in only one direction. Maybe I should add back here, but both are straight. There we go. And then it wants us to turn the ray into a line. So in order to do that, I'm simply going to draw a little bit more of a segment, but I'm not going to end it. I'm going to put an arrow tip on the end, and that shows that it will continue on and on and on in that direction. And we've got an arrow tip up here too, so it continues on in that direction as well. All right, very good. Number 21, think smarter. This is our math on the spot video, which I will be pulling up here in just a moment. But let's take a look at what the question is asking. It tells us to draw a closed shape in the workspace by connecting 5 line segments. So boys and girls, what that basically is telling us is that we need to draw a 5-sided shape, and it has to be closed. So we have to start and end at the same point. So let's take a look at our video. You might remember our friendly guy here who likes to tell us about what's going on in our problem. So let's take a look at the video and we can answer this question together.
I love a line. I love lines because they're straight and they have endpoints when you look at line segments, and it reminds me of a great puzzle that you and I are going to have fun thinking about together. Let's take a look and have some fun with lines. So here's the challenge. Draw a closed shape by connecting 5 line segments at their endpoints. So there's a bunch of words here, and I want us to make sure we understand what all the words mean. So a closed shape with 5 line segments, connecting the line segments at their endpoints. So what do these things mean? Let's start off by talking about what a closed shape is. A closed shape just means a shape that I can draw on a piece of paper that actually starts and ends at the same point. So let me show you some examples of some fun-looking closed shapes where I pointed out where I started and ended the drawing. Check it out. So here, a circle is an example of a closed shape because, see, I put a little dot there. That's where I started, and I came right back to where I ended exactly where I started. A square is another example because if I start right there, then check it out. Boom, 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 boom. I end where I started. This little kind of figure of someone eating something almost. It starts up here, goes around, comes up, goes over, and I end where I started. This, which looks almost like a bee, doesn't it? I start here, go up, around, over, and then back where I started. And then even this thing, which looks like something interesting, goes up, over, and up, get back where I started. And then finally, the triangle is another example of a closed shape, because if you start here, you can actually end there as well. So these are all examples of closed shape. Basically, the bottom line is anything that you can draw where you start somewhere and just end that same place. So that's actually a really crazy one, but you could imagine even a nicer one. That's a closed shape. Now, but we want to do it with 5 line segments. Now, what's a line segment? Well, a line segment, first of all, looks like this. This is an example of a line segment. And the thing to notice about a line segment is, first of all, it's straight. Second of all, it's part of a line. And third of all, it has 2 endpoints. Notice that, in fact, there are 2 endpoints, one on each end, that distinguishes the beginning and the end of the line. So that's a line segment. So for example, here you see we have line segments that make up this closed shape, 4 of them. There are not line segments that make this up because this is actually curvy. There are line segments that make up this shape. There are 3 of them. There are line segments that make up this shape. There are 1, 2, 3, 4, 5, 6 of them. Well, we want to create some closed shapes that have 5 line segments and connecting those line segments at their endpoints. So that's what we want to do. We want to make a closed shape, so where we start is where we end, but we want to use just line segments, and we want to use exactly 5 of them. So let's see if we can have some fun drawing some. So here's one I can draw. I'll start up here, and then I'll go over, down, here, back up, and now I'm going to come over. Now it's closed, and notice that every side is a line segment. It's straight, part of a line, and has 2 endpoints each. And we connect the line segments at their endpoints, which is exactly what we did. And do we have 5 sides? Let's see. 1, 2, 3, 4, 5. So there's a closed shape with 5 line segments, and we connect the line segments at their endpoints. Want to see another one? Let's do another one. They're kind of fun, I think. I think these are kind of fun. I like drawing, don't you? How about this one? Start over here, go over, go down, come over, go up. I can't make a rectangle because if I make a rectangle, I only have 4 sides, so I better cheat and cut across. Check it out. It's like a rectangle with a little piece cut off, And notice I have 1, 2, 3, 4, 5 line segments that make up this closed figure because I ended where I started. Should we try one more just for fun? Let's just do one more. What if I start up here? I go down, I go over, I come up. Uh-oh, I can't make a rectangle. Boom, boom. Ha! Surprise! It's like a dented rectangle, but the dent has 5 straight sides, and you can count them for yourself. 1, 2, 3, 4, 5. And we connected those line segments at their endpoints. You can see those endpoints are highlighted there, and we ended where we started. So there are just a couple of, not a couple, there are actually 3 examples. There are actually lots and lots of different answers we can give. There's not just one answer, or in fact, there's not just 3 answers. You can give your own answers. Just make sure that you use exactly 5 line segments. Those are parts of straight lines that have endpoints, and make sure you connect those line segments at their endpoints. If you do that, and you make sure you start where you end, then in fact, you will have another answer. There are lots of answers in geometry, and it's kind of fun to realize that we can create closed figures just using line segments, even 5 line segments. Have fun creating closed figures, and I'll see you soon.
All right, awesome. So I got an idea when watching his video of how to create my own 5-sided shape that is closed. One of his kind of reminded me of this, but I'm going to draw something. 1, 2, 3, 4, 5. So to me, kind of looks like a house. Here's the segments, and I know it's kind of hard for me to draw this on the computer using my mouse, so bear with me. But there are 5 straight lines that connect and close up that shape. So a typical house, so to speak, kind of makes a 5-sided shape. All right, excellent. Last part on this one, boys and girls, down at the bottom, number 22, we need to draw each shape where it belongs in the table. So we have these 4 plane figures. We need to sort them as being closed shapes or open shapes. So I see this first one here that has 4 sides to it. It kind of looks like a kite. That is all closed up. So I'm just gonna do my best to redraw that shape in the closed shape section. I'm gonna look for another closed shape. It looks like this one here is a half circle. So I'm going to draw that in my closed shapes because it is connected. And then I see 2 open shapes. So I'm going to draw the one that kind of looks, I don't know what it looks like, a boot or a shoe or something, part of a figure's leg. I don't know, but it's open. There should be another line segment there to close it up. And then one that almost looks like it could be made into a triangle, but again, it kind of is just left hanging. It doesn't close up. So those 2 would be open shapes. All right. Now, the next 2 pages, boys and girls, in the lesson are the practice and homework pages. I do encourage you to do these 2 pages. Normally, I know they would be extra effort, but just know that your extra effort is at home and trying to learn as much as you can during these times that we're not at school. So I would suggest pausing the video and doing the practice and homework page on your own if you haven't done so already, and then hit play to come back with me and check over your answers. That is a good way to check your understanding of the lesson for today. All right, so to get started checking over our answers here, boys and girls, it says to write how many line segments the shape has. The first one was done for us. You can see and trace and count that there are 4 line segments. On number 2, 1, 2, 3, 4, 5, 6. 6 line segments. Number 3, tell whether the shape is open or closed. I can very clearly see number 3 is open, and number 4 is a closed shape. It is all of the sides are connected, even though they're not all straight. Number 5, problem solving. Carl wants to show a closed shape in his drawing. Show and explain how to make the drawing a closed shape. Well, that is simple enough, Carl. All you need to do is draw a 4th line segment to connect so that your shape starts and stops at the same point. So we can just tell Carl, draw 1 more line segment. Okay. And number 6, the shape of a fish pond at a park is shown below. Is the shape open or closed? Well, a pond has to be a closed shape, otherwise all the water would be spilling out. So it is a closed shape. It is connected all around. All right. Number 7, draw an open shape and a closed shape. Label your shapes. We can certainly do that, boys and girls. I'm going to use my shape button up here. How about let's see, I'm trying to just play around with some things here. I can do this shape, a star, and a star would be a closed shape. All the sides are connected. And so that would be a closed shape. Woo! There we go. And for an open shape, I don't know. Something like that. Open. Doesn't have to be pretty. Boys and girls, I know I would always complain about our smart board at school and how it would always kind of be goofy, but boy, do I miss that smart board now. All right, last page, boys and girls. Thanks for hanging with me here. How many line segments does this shape have? So if we count the sides, 1, 2, 3, 4, 5. There's another 5-sided shape that's closed up. What is part of a line, has one endpoint, and continues in one direction? So part of a line has one endpoint and continues on in one direction. Drawing it out is a good visual. Think of what we call this. It is a ray. All right, number 3, spiral review. What multiplication sentence does this array show? When trying to figure out our multiplication sentence, think of how many rows. 1, 2, 3, 4 rows. And in each row, there is 1, 2, 3, 4, 5, 6, 7, 8. So this would be showing 8 times, or I'm sorry, we could go 4 for 4 rows times 8, and that equals 32. 4 times 8 equals 32. Number 4, what is the unknown factor and quotient? Oh, we haven't heard those words in a while. Factor is what we multiply, the two numbers we multiply together to get our answer in multiplication. So 9 times something equals 27. Well, I know 9 times 3 is 27, and therefore 27 divided by 9 has to equal 3. That would be my quotient. Number 5, what fraction is equivalent to 4/8? It's kind of hard to see the fractions on my paper here, but if you look in your book as I'm looking in mine, I can see, oh, these are all eighths, duh. So then 4/8 would be half, of my circle, right? When I highlighted 4/8, now I have 4 over here, and then I have 4 on the other side. So I could say 1/2 is equal to 4/8. Or maybe, boys and girls, you looked at 2 of these eighths together, and then these 2 eighths together. And then you could see how our circle could be split into 4 pieces. And 2 out of those 4 pieces would be 4/8. So 4/8 is the same as 1/2 or 2/4. And lastly, Mr. McTavish has 30 students from his class going on a field trip to the zoo. He puts 6 students in each group. How many groups of students will he make? Well, if he has 30 students and he is putting them into, putting 6 students in a group, that means he's dividing. So I'm going to use my fraction bar symbol on the computer to represent division here. So he's dividing by 6 students, and 30 divided by 6 would equal 5. And you could also have written this out using our basic math symbol. 30 divided by 6 equals 5. Alrighty, boys and girls, that is the end of lesson 12.1 for math. Thanks for hanging out with me and going through our math lesson here together. If you have any questions, please reach out to me and let me know. And I wish you the best of luck with completing your assignments for the week. And I will talk to you all very soon. Bye, guys.